Hey everyone, welcome back to Edgeverse, where we break down the latest in AI tech that's changing the game. Today, we're talking about an optical revolution in AI memory. Imagine feeding an AI an entire novel or massive codebase, and it handles it like a breeze, without data overload. That's the promise of DeepSeek AI's new breakthrough, context optical compression, or CC, powered by their DeepSeek OCR model. Have you ever wondered why even powerful AIs like GPT or Claude struggle with really long inputs? It's all about that pesky context window, the amount of info they can juggle at once. We'll unpack why that's a problem, how DeepSeek is flipping the script by turning text into images, and what this means for AI's future. Stick around, because this could be the key to AIs with near limitless memory. Let's dive in. First off, LLMs are incredible. They write code, chat like humans, and reason through complex problems. But they're held back by how they process information, specifically the transformer architecture introduced in 2017 with attention is all you need. The magic happens in the self-attention mechanism, where every word connects to every other one. But here's the catch. The math scales quadratically. Double the input length, and compute needs quadruple. That's complexity, folks. It's like trying to fill a swimming pool with a teaspoon as things get bigger. Early models handled a few thousand tokens. Now, we're up to 1 million or 2 million through brute force and hardware tweaks like flash attention. Still, for true long context tasks, like analyzing a whole book or a giant codebase, it's insanely expensive. What if we change the game entirely? DeepSeek AI's radical idea: don't process text as text. Compress it into an image, a superdense visual format, and let the AI read that instead. This is context optical compression. It's about turning massive text sequences into a picture that packs 10 to 20 times more info per token. The paper claims 100 visual tokens can reconstruct 1,000 text tokens with 97% accuracy. Mind-blowing, right? This could push context windows to tens of millions of tokens, making today's limits look like child's play. To appreciate this, let's quickly glance at what's been tried before. Researchers have thrown everything at the context problem. Sparse attention, like in Longformer, focuses on local neighborhoods, cutting costs. Linearized methods like Liftformer drop complexity to almost linear by projecting into lower dimensions. Then there's Retrieval Augmented Generation, or RAG, which pulls relevant snippets from a huge database on the fly. Great for scalability, but it can miss the big picture if retrieval flops, and it's not ideal for synthesizing across one massive document. Memory tricks like Transformer XL cache summaries of past segments. All solid, but they're tweaks on the same text token foundation. DeepSeek borrows from computer vision to build something new, using Clip from OpenAI, which links images and text in a shared space. And SAM, Meta Segment Anything Model, a beast at breaking images into objects and boundaries. These multimodal foundations make CC possible. So, how does CC actually work? Text is sequential and sparse. But images are dense, spatial, processed in parallel by vision models. Humans absorb tons at once. Why not AIs? CC treats text like a signal to compress lossily into an image, not perfectly, but close enough semantically, like JPEG for words. The pipeline? Step 1. Render the text into a synthetic image, optimized layout, tiny font, packed tight for machine eyes. Step 2. Feed it to a vision encoder that spits out a handful of visual tokens. These go into the LLM's context window, slashing the token count. Need the details back? A decoder reconstructs the text from those visuals. Why no? Foundation models like SAM and Clip are so advanced they capture fine details and semantics. Plus, language has redundancy, so lossy compression works. The big win? It shifts compute from ongoing attention to a one-time encoding upfront. For a fixed big document, you encode once, then query cheaply forever. Now, let's geek out on the architecture. DeepSeek OCR uses a two-stage encoder for balance, global semantics plus fine details. Stage 1. A clip-based vision transformer grabs the big picture, processing patches and outputting features tied to language concepts. Stage 2 layers it with CNNs for local patterns and SAM's encoder for structure, like line breaks and word boundaries. Fuse them via cross-attention or concatenation, and boom, compact visual tokens that are semantically rich and precise. The LLM then uses these as context for tasks or reconstruction. It's like giving the AI X-ray vision for text. But does it work? DeepSeek's experiments say yes. They tested on diverse datasets like the pile, compressing and then reconstructing. Key result: 1,000 text tokens into 100 visuals, reconstructed at 97% accuracy. That's 10 times compression without losing the plot. They scaled it up, showing accuracy holds for longer inputs. Ablations prove the two-stage setup is key drop 1 and performance tanks. Pre-training from CLIP and SAM is non-negotiable. This isn't hype, it's empirical proof that visual compression beats text for AI memory. CC keeps the whole context intact, unlike RAG's chunks. It slashes tokens deeper than efficient attention. Downsides? Upfront encoding is heavy fine for static stuff, but not real-time chats. And that 3% loss? Could hit numbers or rare words hard, risky for finance or medicine. Scalability to millions? Vision models might struggle with ultra-dense images. Plus, debugging. That synthetic image is machine-only. Humans can't read it if something glitches. But the upsides? Revolutionary. We're talking AIs with perfect memory, ingesting libraries for expert reasoning, personalizing from your life data, or spotting science breakthroughs across papers. And beyond text, imagine compressing audio spectrograms, spreadsheets, or code into visuals. Images as universal AI memory chips could unify modalities. Could this be the shift from linear AI brains to something more human-like, parallel, associative, compressed? Wrapping up, DeepSeek's CC isn't just a fix, it's a rethink. By turning text into images, they've cracked open doors to AI with boundless memory. If it scales, we're in a new era. Challenges like cost and fidelity need ironing out, but the potential? Game-changing. If this got you excited about AI's future, smash that like button, subscribe for more deep dives, and drop a comment. Do you think optical compression will redefine LLMs? Thanks for watching. See you next time.